Hi guys, I'd like to welcome us to another discussion on the concept of integration. Now today we're going to look at the concept of the general power rule that we had discussed as one of the rules which are going to apply in trying to deal with the differential functions or rather what we refer to as exponential functions. And that one consisted of some of the functions which have got what we refer to as exponents. So for today, I'm going to just remind us of the power rule or the what we are referred to as the simple power rule and how we can be able to relate it to the general expression for the power rule. And we are given in our first case the a simple power rule for integration as xn, and then this is of dx. And we said that for such a kind of integration, we are going to have this specific power for x for n raised to x raised to n, whereby we're going to increase this specific exponent by 1, and the result of that is going to form our denominator for this specific expression, and then it's going to be given as x n plus 1 over n plus 1 plus that specific constant. Now for the general power rule, we're going to see that if u is a differentiable function of x, so we're going to have a relationship between the u and x, and then we say that if u is a differentiable function of x, then we're going to see that if we have an integral over u raised to power n, and then we have what we call dx, we can be able to create a relationship that is going to, in a sense, give us the general expression whereby we're going to have this one represented as the integral. Let me just use a different, just a continuation of this. Have this one as du over dx given as such. So this is going to give us a result of a general expression whereby we're going to have the integral of un du. And from this one, we can be able to use the expression for the general symbol rule, or rather for the symbol rule, in order to find this specific integral. So for the symbol rule, we said that if given such a kind of a function, then it's going to be un plus 1 over n plus 1, and then this is going to be plus c. So therefore, the general power rule is going to, of course, assist us try to find an integral from this specific function. And in some aspect of this, we are going to convert it into the symbol rule, which is going to assist us apply that general expression that we have mentioned in our first discussion. So in this case, we're going to see that there's going to be a condition that is going to be attached. We had talked about the concept of these specific fractions that we had said for if a value of a over b is being given, there's a condition whereby we're going to see that if the values of this particular fraction or is going to exist, then therefore we're going to have a b not being equivalent to basically 0, because if b is 0, then it's going to be indefinite, and therefore for this we're going to have a situation whereby n is not equivalent to 1. So therefore this is going to hold for this specific integral for the general power rule. So we are going to use an example and try to see how this specific case for the general rule can be applied in trying to find solutions for some specific functions. So I'm just going to give an example, and we're going to use that one to try and find an integral over that specific function. So suppose we are required to find an integral of a function. This is 3x minus 1 to power 4 dx. I'm going to use the general power rule and try to find how we can be able to interpret this specific general power rule. So given such kind of a function, then we're going to first identify a factor that is an integral, an integrand that is raised to a power, and basically this is a first section which is 3x minus 1 raised to power 4, and this is going to form our exponent. So therefore we're going to find a derivative of this specific function, and therefore which is going to appear in terms of the function of u that I've mentioned in our specific or a general power rule. And we said that if we use a differentiable function of x, then we can be able to use this specific concept of u in trying to find a description for a relationship that is going to exist between this exponent and the general integral expression which I've given on the board. Therefore, as I've said, this is going to form a factor of u, of course, which is going to form a factor of u, which is a factor of the integrand. And therefore, we're going to represent that specific part as a factor of u, whereby du of dx is also going to be a factor of the integrand. Therefore, if we try to create a relationship between this specific exponent and u, we are going to say let u be represented by 3x minus 1. And therefore, from this specific point, we're going to look for a factor which is du over dx, which is going to be the derivative of this specific factor, which is, of course, u that we have said is a differentiable function. And then we're going to get this one as 3. So therefore, in us trying to represent this in terms of u, we're going to find this one as a subject, or rather write it in form of u. And now from this, there's an implication that therefore dx can be represented as du over 3. And therefore, if we try to do a substitution for this first case for our summation, which is 3u raised to power 4, and then for dx, we're going to have this one du over 3. Now that one is going to create it to be more simpler for us in trying to, of course, do this specific operation. So therefore, we're going to have this the integral of u raised to power 4 to du. So using the general, of course, rule that we had done for integration for this specific case for the power rule, then we can be able to give this one as u raised to power 4, u raised to power 4 plus 1, which is 5 divided by 5 plus c. But we had given a condition that this specific function for u can be represented using 3x minus 1. So we're going to just restore our equation, our specific expression, of course, as 3x minus 1 raised to power 5 over 5 plus c. So this is this effect of trying to create the concept of a u is going to assist us to make it simpler for us to find the integrals of various functions. And this is one of the examples in which we are going to use the general power rule and the simple power rule in trying to find integrals of various functions. So in our next discussion, we're going to look at a second example, and that is of course going to entail another rule that we had looked at under the 4 rules of integration that are given on the board in our first discussion. So catch us in our next video as we check on that, how we can be able to tackle that specific example, and check on our description box for a link for other videos which are similar. So that is it for now, guys. Bye, God bless you.